On this episode of AvTalk, we are joined by Malcolm Ridley, the Chief Test Pilot at Airbus Commercial Aircraft, to learn more about what exactly a test pilot does besides wearing those sweet orange flight suits. Hello and welcome to episode 135 of AvTalk. I am Ian Petchnick, and in just a moment I'll be joined by Jason Rabinowitz. We've got a great show this week with Malcolm Ridley from Airbus, but before we get to our conversation with Malcolm, a few odds and ends. We'll have full coverage of third quarter results from Boeing and various airlines in next week's episode. And last week, we asked for ideas about why the Northern District of Texas was chosen as the venue for Boeing's deferred prosecution agreement previously and the charges against Mark Faulkner last week. We got a surprising number of responses. Apparently, a lot of you are lawyers. Who knew? And the consensus seems to be that because the named impacted airlines, quote, Airline 1 and Airline 2, unquote, are based in the Northern District of Texas, the decision was made to charge the case there. That actually seems to make a whole lot of sense. So, lesson learned. With that housekeeping out of the way, on with the show. We are joined this week, as promised and kind of previewed over the past couple of weeks because I've been so excited about this conversation. We are joined by Airbus's Chief Test Pilot, Malcolm Ridley. He is here to talk to us about being a test pilot and then some of the things that he has worked on in the past and is working on in the present and possibly in the future. Malcolm Ridley, thank you so much for joining us. It is a pleasure to have you on the show.
No, Ian, the pleasure is all mine. Thanks very much for the opportunity. It was great to see you guys at the Airbus Summit recently, and it's a great pleasure to join you again.
Yeah, thanks for coming on, Malcolm. When Ian was out in, I believe it was Toulouse, he could not stop talking about how enjoyable it was talking with you. I was kind of insulted that I don't get that kind of compliment, but I'm very excited to speak with you and hear about your experiences as the Airbus Chief Test Pilot.
So I guess the first question that we have is, how do you become a test pilot, let alone the chief test pilot?
That's a great question.
It is a great question. And the truthful answer is there's a lot of luck involved and being in the right place at the right time, guys. Honestly, the most well-trodden path to test flying, particularly until the modern era, has been through the military. And that indeed was my path. I started my career as a pilot with the Royal Air Force in the UK. And I was lucky enough to get the opportunity to train there as a test pilot before continuing to work in the military as a flight test pilot, largely on heavy aircraft, and later as an instructor. And that often is the main route into experimental test flying. As time's moved on, there's more opportunities now to do it in different ways. There are a number of commercial test pilot schools out there on the market that are offering appropriate courses. So the world is opening up.
What kind of aircraft did you fly before your time with Airbus and the military side of aviation?
My career was in maritime patrol aviation. I flew the Nimrod maritime patrol aircraft in the Royal Air Force, and then I was extremely fortunate to spend 3 years on an exchange posting with the Royal Australian Air Force flying the Lockheed P3 Orion.
Nice.
Yes.
So what you mentioned that previously the military was the path to becoming a test pilot, but now that there are kind of commercial test pilot schools, what is I assume there are many differences. What are some of the differences between just being a pilot and being a test pilot?
That's a great question. And the first prerequisite really for test flying is to be an experienced pilot, either in the military or commercial environments. Because the whole point of test flying is to develop aircraft that will work well in the hands of the user. And unless you've been the user in the role that you're proposed to fly the airplane, you really can't comment on how it should be designed and how it should work. So the first prerequisite is a good amount of experience on those classes of aircraft that you're going to test. But then really the main difference is that we're testing the machine, in the hands of a commercial pilot or a military pilot in service. The airplane has to do a job, but first and foremost, it's a machine. So we have to make sure that that machine is both safe, efficient, and effective to fly. that it's well designed, that it operates correctly, and it meets the requirements of the certification agencies and the end user. And part of that, of course, is employing our experience to understand how it will be used in service. So our job is really operating the machine, testing the machine, but then also projecting ahead as to how that machine will work in service and how it will be used.
So that's really interesting. You're like the beta tester, the alpha tester of the aircraft. And I'm really interested to hear, how do you really interpret what you're experiencing, what you're seeing, what you're feeling to the engineers or the other teams at Airbus when you're flying a new aircraft? How do you really communicate what you're experiencing into something that's actually actionable?
Another really great question, Jason. A significant part of test pilot training, wherever you do that training, a significant part of it is communication. It is how to communicate technically, logically, in a data-based way that really explains what you see and what you observe in the air in a way that's both engineering literate in terms of being able to fix the problem, but it's also user literate in terms of what will this mean to a pilot using the aircraft in service. So it actually starts before the flights, because a lot of the stuff we do, particularly in terms of design and development, is done in simulators before we even get in the airplane. We then fly the airplanes to confirm or improve on our understanding that we see in the simulator. And even during the flights, we're able to communicate, because for the majority here at Airbus of our experimental engineering test flights, we're followed by telemetry. So in real time, we've got guys on the ground, our design experts, our engineering experts are effectively with us in the airplane, listening to what we have to say, observing what we're doing. Then after the flight, we'll have a comprehensive debrief where we'll sit down with those guys and we'll again go through what we've seen, draw our conclusions, make our recommendations. And then this, of course, is followed up by documentary work as well, where we will write reports with our flight test engineers to document our findings and put them in context.
When you're working on a new aircraft or a new system on an existing aircraft, you said you start with documentation and then you move into the simulator. Are there ever any times when you get to the point where you say, before you've even flown the aircraft, where you're like, oh, we don't think this is going to work, so let's take a step back before, or perhaps when you're surprised by something positively, you're like, I don't know if that's going to work. And then sure enough, it all works the way that it was designed to, where you've been kind of surprised either way.
Indeed, yes, is the short answer. You know, the whole purpose of flight test, in a way, if you want to look at it this way, is to reduce surprises. We don't want any surprises at all when the aircraft is in service. We want to take the surprises on the chin in the flight test and development world. So yeah, we do certainly find things in the development simulators that we don't think will work well in the air. And we find things that in the air that perhaps the simulator model didn't correctly predict, or indeed that are actually better than we expected, as you've said. So yes, absolutely, modeling gets better and better, but for the moment, there's no replacement for actual flight test and actually flying the airplanes.
Besides doing the actual flight testing and flying the aircraft, flying simulators and things like that, what else is a test pilot? And you as chief test pilot for Airbus, what else are you working on besides just flying the aircraft?
Okay, so at any stage of a program, we're also providing operational input into our design offices. We work closely with our flight standards and training guys as well. There's another group of pilots within Airbus who look after training policy, training design. They also provide the procedures that flight crews will use in service. We work very closely with those guys to develop together those procedures and processes. Another very, very important part of what we do is, of course, safety. And my previous job before being the chief test pilot was to be responsible for the safety management system here in our flight test and integration center. So we always, always, always put safety first in terms of what we do within the company, but also in terms of our products in service. So everything we do has that safety vein running through it to make sure that that we're doing the right thing. So before any significant flight test campaign or development phase, we will sit down, we'll go through the safety aspects of this, we'll try to predict the hazards and risks and mitigate them as appropriate. And then we qualify the risk of what we're about to do in terms of its acceptability. And management of risk is always a balance of the potential adverse outcome versus the reward. And in flight test, it's particularly sharp. We really need to make sure that we're getting that balance right. So that's a key part of what any flight test flight crew is going to be involved in their job.
So definitely a lot going on at any given moment. And I want to take a little look into your past at Airbus and ask, what have you worked on at Airbus in the past during your time there? Like aircraft in general, what aircraft, new aircraft being flight tested, have you worked on specifically? I'm guessing it works that you jump on a project from the beginning and you see it all the way through to the end when the aircraft is delivered and in service, or is there more flight testing that goes on beyond the delivery?
So the way we organize is that for particular programs, we will put pilots and engineers onto that program as a specialization. So you're absolutely right, Jason. They will follow through that program from beginning to end as far as possible. But we also all do a bit of everything. So here at Airbus, we have the philosophy that our flight test pilots will cover the full range of our programs, all of our aircraft types, and the kinds of flying that we do, both the development and experimental flying, but also the production flight testing and customer acceptance flights that we do as the customers collect their aircraft. We think it's very important that pilots remain familiar with all of those areas, keep contact with our customers, but also work at the cutting edge of the development work that we're doing. So yes, I've done a range of things in the 10 years I've been with the company. And I've got to say they've been the 10 most fulfilling years of my career so far by a long way. So I've worked on all the major programs, including the military A400M at various times. I can remember some notable moments in that program being high altitude parachute testing from depressurized aircraft at high altitude. I also claim the record for perhaps the highest ever opening of the direct vision sliding window in the A400M, which is, I think, was 22,000 feet.
A little windy, probably. Huh?
It wasn't, surprisingly not, actually. But yeah, that's a program highlight for me, flying with the windows open at 22,000 feet.
So it definitely sounds like the A400M is probably your favorite test program so far.
It's certainly up there. And the A400M is a wonderful machine. It's a wonderful machine to fly. It's a stupendous achievement.
Have you actually been on the first flight of any of these new aircraft at Airbus?
Yes, another memorable day for me was being one of the pilots on the first flight of the A319 Neo with the CFM engine, and indeed also the very first flight of the A330-800 3 years ago or so. It's a real privilege because as a test flight crew, and I include of course, my colleagues, the flight test engineers and test flight engineers with whom we fly. It's a huge privilege to take part in an occasion like that because we are just the tip of the iceberg on a day like that. The thousands actually of people, both within Airbus and our suppliers, who have put their hearts and souls into getting that airplane to the point of first flight is quite humbling. We feel very privileged to be the people who are standing there accepting the applause at the end of the day, but actually, we're doing so on behalf of a huge team. And this is one of the things that I think we all truly value in this industry. And it's particularly noticeable in flight test is this wonderful feeling of teamwork that we have in the company. These areas of expertise that all have to fit together perfectly like a fantastic jigsaw puzzle to bring these things to fruition. And they always do. We always do it. And to see that crowd of faces, the happiness and the pride on those faces is awe-inspiring, to be honest. It's fantastic. So those occasions stay with me.
You mentioned teamwork. And I want to touch on that for a minute because I would like an explanation about the difference between a flight test engineer and a test flight engineer.
Right. And I knew you would. So, as you well know, let's start in the cockpit. Our aircraft are designed to be operated by two pilots, okay? But they have a third seat in the cockpit for observer status or for a third pilot who's traveling on the aircraft. In fact, in flight tests, the workload can be significantly higher than it is in a service aircraft, as you can imagine. Some of the tests we do are very intense in terms of workload and demand on the flight crew. And indeed, even on occasion, both pilots can be fully occupied actually piloting the aircraft. There are tests where one pilot is solely concentrating in roll and another pilot in pitch, for example. Or indeed, the flight control system of the airplane has been deliberately degraded so that we can test failure modes, in which case the piloting task itself can be very demanding. So it is extremely important, in fact, it is vital to have a third person in the cockpit to assist. To give you an example, let's take the example of an engine relight test. So this is something we will need to do with a new or modified engine, or indeed during the development of a new aircraft, is to establish the envelope, as we call it, through which an engine might be restarted in flight if it has been shut down. And this will take the form of a maximum altitude limit and a speed or Mach number range in which we can get that engine running again. So to test that, we will have to set up the airplane very precisely at the test point required in terms of speed and altitude. And that will require the full resources very often of both pilots to manage the energy to get to the airplane to that correct point. So it's very helpful in this case to have a third person who can concentrate purely on the actual engine itself, can shut it down, and then can commence the restart and monitor very closely the parameters of the engine as it's restarting and take action quickly if there's any problem. So that's, to me, a perfect example of why we need three people in the cockpit. And the third guy is a test flight engineer. So they're highly skilled, qualified guys who follow each of our development prototype by tail number through its life. And they get to know extremely well the limitations of that particular prototype, its engineering history. They liaise directly for us with the ground engineering teams to have the aircraft prepared in exactly the way, the configuration, weight and balance, etc., that we need for a particular test flight. So that's the test flight engineer who will be with us in the cockpit. And then the flight test engineer. Now, these are the guys and girls who will work at the flight test engineer station in the rear cabin of our prototypes. And they are the guys and gals who will follow through the program, who will put together the test flight profiles, who will work with us to consider the safety of the test, who will plan each individual flight and each test campaign to get the maximum efficiency out of the test program. And then in flight, they will direct the testing. So one of the pilots will be the captain of the aircraft, but the lead flight test engineer for that flight will manage the flight. They will guide us to the test points, and they will take us through, if you like, as test directors. And then they get to write the majority of the reporting and hard work after the flight as well, which is great for us pilots, but less so for them. But they're fantastic experts. They're real assets to the company. And no flight test department could function without highly competent and skilled flight test engineers, test flight engineers, and indeed test pilots.
When we were in Toulouse last month, I had the good fortune to tour the A350-1000 test aircraft.
Right.
And I noticed something on the flight deck in the center console that was the escape system. Flight test emergency evacuation system. And I was speaking with I want to get this right, the lead flight test engineer. And he said that had been deactivated, but was used for early flights. Can you explain what that is? And I'll post a picture for everyone listening. I'll post a picture of this in the show notes so you can see the switch that we're talking about.
Right. I can tell you what it is and how it works, but I'm happy to tell you that I've got no personal experience of using it.
That was going to be we probably would have known if that had happened.
So during the very early flights, particularly the critical flights of the flight test program of a brand new aircraft, For the first prototype, maybe I should rewind just a moment and explain our philosophy with the prototypes, because for a major campaign such as A350 certification, we will have a number of prototypes. And for the A350, we had 5. So we had 2 aircraft that I would describe as heavy prototypes with the full range of flight test instrumentation, such as you saw, Ian, at Toulouse, which is essentially the interior of the aircraft. There's no cabin. The interior of the aircraft is largely computer racks, water ballast systems, computers, and recording devices, and the stations for the flight test engineers. So it's very workmanlike. And then we will have 2 prototypes, in this case, that have a representative cabin fitted, because we need to test the cabins. We need to measure vibration, noise, air temperature, etc. Now, of those heavy prototypes, one of them will be dedicated particularly to tests such as envelope expansion, the early progression of the aircraft to high speed, high altitude, high Mach number, and indeed high angle of attack, where we first start to take the airplane up to the stall. And it will also be involved in tests such as flutter, where we deliberately try to excite vibrations within the aircraft, particularly in the high-speed regime, to ensure that those vibrations will never become self-sustaining or divergent, as we would call it, so that the structure of the aircraft is at risk. So clearly, we have to go there and do this to ensure that the airplanes are safe before certification and they meet certification requirements. But we have to accept a certain amount of risk in doing so. So for those prototypes, we will typically install a means of escaping from the aircraft in flight. And this largely covers the case where we manage to damage the aircraft to an extent where the landing would be in doubt, and the safest option for the crew would be to jump out. So what we do is we will typically in our airliners, we will put a hatch, which is within the forward cargo door of the production aircraft. And we'll put a tunnel that comes down from the cabin floor down effectively through what is going to be the forward cargo in the production aircraft, down to this hatch in the forward cargo door. And once the system is armed, if it's needed to be used in flight, then basically it's a single action on a lever to depressurize the airplane rapidly, and then using pyrotechnic explosives, we remove that outer hatch, leaving an escape path for the crew to leave the aircraft by parachute. Clearly, that's for the particularly sharp-edged tests, as I might call them, the particularly high-risk ones. Once we're through that stage of the program, then honestly, there is the requirement is no longer there to have that emergency escape in-flight capability. So typically, we disable it and remove it because we don't want to fly around in aircraft that are carrying explosive hatches. And
probably a good idea.
Good to have, but never good to use.
Absolutely.
So we touched on this briefly in a conversation last month, and I wanted to kind of draw a little bit more out because I thought this was fascinating. We were talking at the Airbus Summit. A lot of the conversation was about what's next, electric propulsion, hydrogen, and things like that. And I made an offhanded comment that something to the effect that you'll be busy soon. And you said, no, I'm busy now. And the comment that you made was, well, we have to design what the aircraft is going to look like as far as pilots are concerned. And I was hoping that you could expand on that and talk about some of the things that your work involves in getting the next generation of aircraft.
Gosh, well, the next generation of aircraft, there are various aspects to what could be the next generation of aircraft, ranging, as you've suggested, from the Airbus Summit. We're looking at a range of possible propulsion systems for the next generation of aircraft. We are also continuously developing air traffic management technology with the air traffic management service providers. We're always looking at new ways of presenting information in cockpits, flight guidance, automation capabilities. We're always looking to move forward. And the point where those come together to make the next generation of aircraft is not so far away. We're always moving forward here in Airbus. We see ourselves as innovators. We've got a track record of that in the industry with our fly-by-wire systems and flight envelope protection. So we're always looking for what's next. And that was the basis of my comment. So yeah, in particular, you'll have seen that we've just been developing new technologies for automatic control and guidance of our aircraft to give much more flexibility to pilots in the future. The specific example I would mention would be the AvTalk project. Last year, we completed the AvTalk project, which is the automated taxi takeoff and landing demonstration using the A350. We use the A350, but it's purely an example. It could be used on any of our aircraft in the future. But this allowed us using visual recognition means, visual sensors, to provide a completely automatic taxi, takeoff, flight, and automatic landing using visual sensors. The advantage of this is we're not dependent for automatic landing on ILS or ground-based GPS. We are entirely self-contained with the aircraft, and that opens up the whole flexibility of doing auto lands at much less developed airports around the world. In fact, any airport would potentially be possible in the future. That's just one example of the way we're always pushing technology forward. So that's a technology that is nowhere near ready to go into a commercial aircraft yet, but could potentially be in the next generation.
We have one more question for you, and it's a question that we try and ask everyone that we talk to. What is your favorite part of the job?
It has to be the flying, Ian.
That's the only correct answer.
It has to be the flying. I feel extremely privileged, and I'm sure there are many pilots who will be listening to this. All I can say to them is I understand how lucky I am. Every flight I make here is interesting in one way or another. Either it's because we're testing something new, we're developing one of our existing products to make it even better. But whatever I do, it's always pushing a little bit further with the technology and the capabilities of our aircraft, and I find that fascinating. It's demanding in terms of the skill I have, and that's always, I think, to any professional, anybody likes to have their skill challenged and pushed and to be doing the best they can. But another real pleasure I get from it, of course, is flying with our customers, and our customers come here to collect their lovely new aircraft, and I have the privilege of flying with them from time to time to ensure they're happy with each aircraft as it's collected, and that's a real pleasure as well. So it's the flying. I love the teamwork. I've got a fantastic team of colleagues here, both here in Toulouse, but also my colleagues and friends in Hamburg, in Germany, in Mobile, Alabama, and in Tianjin in China are 4 flight test locations. It's a fantastic team, and I have pleasure every day in working with those guys. I learn something every day. But the pleasure, it's the flying.
Awesome.
And on that note, we will say thank you very much for joining us. We have been regaled in conversation by Malcolm Ridley, the chief test pilot for Airbus commercial aircraft. Thank you so much again for joining us. I'm very, very pleased that we were able to sit down and talk.
Ian, Jason, it's been a pleasure. Thanks very much for the opportunity. I could talk all day, as you probably guessed.
We'll have to have you back on another episode then.
With pleasure.
Thank you, everyone, for listening this week, and we hope you enjoyed the conversation with Malcolm Ridley as much as we did. I know I had a lot of fun, and Jason did as well. If you like what you're hearing, please do leave a rating or review. It helps other people find the podcast, and we very much like it when that happens. So please, if you feel so inclined, let other people know just how much you like the podcast. And if you don't like the podcast, say that too, and let us know what we can change to make it better. We are always looking for ways to improve. This has been episode 135 of AvTalk. Thank you so very much for listening.